Greetings and welcome to the Introduction to Astronomy. In this episode of New Discoveries in Astronomy, we will talk about how scientists are reading ancient chemistry on Mars. So let's get started. How do we study an environment that disappeared billions of years ago? Mars today is cold, dry, and hostile. But ancient Mars may once have been very different, and some of the evidence may still be preserved inside its rocks. Recently, NASA's Curiosity Rover identified a wide variety of organic molecules preserved in ancient Martian rocks. The discovery was made in the Glen Torridon region of the Gale crater, an area believed to have once contained water-rich environments favorable to complex chemistry. Importantly, this does not mean life was discovered on Mars, but it does show that ancient organic chemistry was preserved for billions of years. The challenge is that these ancient environments no longer exist. Scientists cannot directly observe ancient Martian lakes or atmospheres. Instead, they must study the chemical traces left behind inside rocks. Some minerals, especially clay minerals formed in water, are particularly good at trapping and preserving organic material over immense periods of time. To study these materials, Curiosity used an onboard laboratory called SAM, the Sample Analysis at Mars Instrument Suite. In this experiment, scientists added a chemical called TMAH to break larger organic molecules into smaller fragments. These fragments could then be analyzed by SAM's instruments to identify their chemical structure. This allowed researchers to detect more than 20 different organic compounds. Among them was a nitrogen-containing molecule similar to chemicals involved in building DNA on Earth. This is where chemistry becomes inference. Scientists are not directly observing ancient Martian life. Instead, they are analyzing preserved molecules to reconstruct the chemical environment that once existed on Mars. The presence of these organic compounds suggests that ancient Mars had conditions capable of supporting complex chemistry. And because these molecules survived for billions of years, it also shows that signs of ancient environments can remain preserved beneath the Martian surface. The study identified a surprisingly diverse range of organic molecules preserved in rocks roughly 3.5 billion years old. That's the key result. Some of these compounds are chemically similar to molecules involved in biological processes on Earth. However, the rover cannot determine whether these molecules came from life, geology, or meteorites, and that uncertainty is important. What this discovery really shows is that ancient Mars once had environments where complex organic chemistry could exist and persist. We cannot travel back to ancient Mars, but the chemistry preserved inside its rocks acts like a record of the planet's environmental history, not by directly observing the past, but by interpreting the molecular clues that remain. So that concludes our discussion on reading ancient chemistry on Mars. We'll be back again next week for another new discovery in astronomy. So until then, have a great day, everyone, and I will see you in class.